Let us first understand what unsupervised learning is. It is a type of machine learning where the algorithm learns from unlabeled data without any explicit guidance or predefined targets. The algorithm explores the inherent patterns, structures, and relationships within the data to discover useful insights and make sense of the information. Unsupervised learning algorithms are tasked with finding patterns or clusters in the data, identifying anomalies, reducing the dimensionality of the data, or generating representative models of the data distribution. Unsupervised learning plays a crucial role in exploratory data analysis and enables the discovery of meaningful information without the need for explicit labels or prior knowledge. Now we must understand the algorithm DBSCAN. DBSCAN is particularly effective in discovering clusters of arbitrary shapes and is robust to noise and outliers in the data. Unlike traditional clustering algorithms like k-means, DBSCAN does not require specifying the number of clusters in advance, making it suitable for scenarios where the number of clusters is unknown or varies across datasets. The key concept behind DBSCAN is density. It defines clusters as dense regions of data points separated by regions of lower density. DBSCAN classifies data points into three categories. Core points. These are data points that have at least a specified number of neighboring data points, defined by the parameter min-pts, within a given radius, defined by the parameter epsilon or epsilon. Core points are the foundation of clusters. Border points. These points are within the epsilon neighborhood of a core point but do not have enough neighboring points to qualify as core points themselves. They are considered part of a cluster but are not significant in defining the cluster's structure. Noise points. These points are neither core points nor border points. They are isolated points that do not belong to any cluster. We can understand the process through the following steps. 1. Select an arbitrary unvisited point. 2. Find all points within the epsilon neighborhood of the selected point. If the point has at least min-pts within its epsilon neighborhood, create a new cluster and expand it by finding more density-connected points. 3. Repeat the process for all density-connected points until no more points can be added to the cluster. 4. Move to the next unvisited point and repeat the process until all points are visited. 5. The output of DBSCAN is a set of clusters, each represented by a group of connected points, and a set of noise points that do not belong to any cluster. DBSCAN algorithm is used in many real-life problems like analyzing traffic pattern in transportation, identifying customer segments for targeted marketing campaigns, detecting unusual patterns in patient monitoring data. We will see its applicability in transportation. Analyzing traffic patterns for efficient route planning. DBSCAN can be applied to analyze traffic data collected from sensors, GPS devices, or other sources to identify clusters of similar traffic patterns. By grouping together vehicles that exhibit similar behavior, such as speed, direction, or congestion levels, transportation authorities can gain insights into traffic flow patterns. This information can be utilized to optimize route planning, manage traffic congestion, and improve overall transportation efficiency. Capturing and analyzing the abnormal traffic is one of the most critical issues in keeping a network under control. Abnormal behaviors are referred to the behaviors caused by attacks which infect normal operations of the Internet, such as worms and DDoS, etc. Those attacks will generate huge number of traffic packet and cause changes in the flow patterns. Abnormal behavior detection is defined as how to discover those attacks by analyzing the flow patterns using different methods, such as DPI and statistical methods. The framework for degree calculation, characteristics measurement, and abnormal users' location extraction is divided into 4 steps as shown in figure. Step 1. Traffic data collection. Step 2. Traffic feature generation and analysis. According to the definition of the traffic features, traffic packets are processed and then the traffic features are extracted. Step 3. Clustering analysis. Based on the features extracted, we employ the DBSCAN methods to cluster the packets into different clusters. Step 4. Abnormal detection.